Hi and welcome back. In the previous session, we looked at some parameters that can help us tell how useful a data set might be and how we could use that data set. Now these were precision, accuracy, validity and variability. Now we're going to start considering some types of early data analyses that can give us some basic idea of what our data is trying to tell us. Let's go back to our apples and imagine we've weighed 11 of these to the nearest gram. We'll have a quantitative, continuous data set because our data consists of numbers along a range which might look like this: 124, 145, 121, 154, 160, 122, 152, 121, 156, 128 and 155 grams. Now, assuming we are comfortable that our measurements are sufficiently precise, accurate and valid, we can be confident that they will be representative of the entire box of apples. We'll now analyse the raw data to tell us the following: the average weight of apples in our sample, the variability of individual weights in our sample, the median value, and the sample mode. First, we can determine the average or mean weight. To calculate this, we add up all the values in our data set. In this case, our samples weigh a total of 1538 grams, and then divide this by the total number of points in our data set. In this case, we have 11 points, to give us an average weight to the nearest gram of 140 grams. This gives us an idea about the size of the apples we've harvested, but we've no idea how much variation there is between the largest and smallest apples, and if any sizes occur more frequently than others. We can get an idea of how much variability there is amongst our sample by calculating what is called the standard deviation of our data. Simply, this is a measure of the average amount that the weight of each apple varies from the overall average weight, and it gives us an idea of the range of weights of the apples in our sample. For example, now assuming that the weights of our apples are distributed evenly around the average, statistics tell us that about 68% of the apples in the bin will weigh between the average minus 1 standard deviation and the average plus 1 standard deviation. It's a bit of a complicated formula, which we'll cover at a later date, but in this case, the standard deviation of our data set is 16, and this means that about 68% of our apples will weigh between 124 grams, which is our average of 140 grams minus our standard deviation of 16 grams, and 156 grams, which is 140 plus 16. The remaining 32% will be outside this range. And that gives us an idea of the range of weights in our sample of apples. This probably will be an important bit of information for our customers. Now, two other calculations can give us additional information about the distribution of weights of apples in our sample. The data mode simply is the weight that appears most often in our sample. In this case, it's 121 grams, as there are two apples weighing 121 grams. In small data sets like this, you may not get a modal figure. In other data sets, you may get more than one. This information gives an idea of the weight or range of weights that occur most frequently and is often useful information for processors and retailers. The other calculation we can easily do is to find the median value amongst our data. This is the value in our data set that has the same number of data points above and below it, regardless of the value of those points. In this case, the median value is 145 grams, and you can probably see why I chose an odd number of data points. If you had an even number, the median will be the average of the central 2 points. Median values are used to get a feel for the middle part of a sample, when one or two very high or very low points may pull the average away from a meaningful figure. You'll often hear the median property prices being used by real estate folk to avoid a market analysis being skewed by one or two very high values. Now, I reckon that'll do us for now. There's a lot to think about there, and there's a lot more to come. Next, we'll have a look at other ways of looking at data, literally through graphs and other visual methods. I'll see you then.